This episode is sponsored by Kendo UI. Kendo UI allows you to build better apps faster. They have a comprehensive library ranging from data grids and charts to buttons and sliders. Plus, you can use their components as plain JavaScript as well as in Angular, React, and Vue. They have a large collection of customizable popular themes like Bootstrap and Material. Go check them out at reactroundup.com/KendoUI.
Hello and welcome to a new episode of React Roundup. Today I'm going to be your host. My name is Nader Dabbit. On our panel today we have Lucas Harish.
Hello, everybody.
I probably said that way wrong. Huh?
No, it's great. It's great.
Normally Charles does the intros. Anyway, today our special guest is Radoslav Stankov from Product Hunt. Welcome to the show, Rado.
Hi. Hello. Glad to be here.
Yeah, we're glad to have you. You all at Product Hunt are doing a lot of interesting stuff, not just around React, but around a lot of cool technologies in general. I think we're going to cover a lot of that stuff. So our topic today is going to be kind of around React at Product Hunt, and we're going to be talking about server-side rendering. We're going to be talking about GraphQL. We might even touch on some React Native. But before we get into any of that, do you mind giving us a quick introduction of yourself?
Yeah, so I'm Rado, I'm head of engineering at Product Hunt. I have been in Product Hunt for the last 4 years. I'm doing software engineering since 2002. I have passed through a lot of stages, so I think of myself like a full stack developer. And the last couple of years, I'm doing a lot of React. I'm based in Sofia, Bulgaria, where I organize the React Sofia meetup, and I'm organizing a React conference.
So what React conference are you organizing?
So it's called React Not a Conf, because originally it shouldn't have been a conference. It should have been like a bigger meetup. But when you invite multiple speakers, it blew up a bit. So it became a conference, and we decided to keep the Not a Name conference just for the fun of it. And also all the speakers get Not a Speaker t-shirts, that in this get Not Listening t-shirts, and you can do a lot of cool jokes around that.
Oh, that's pretty cool. When is that conference happening, by the way? Do you want to talk about how people can sign up for it or anything?
I mean, it happened this April. This was when it happened last, and it will happen next year around April as well. I would give you the website link so you can put it in the show notes, because I haven't set up the MailChimp sign up yet for the next conference.
Cool. Very cool. Yeah, I'd love to check that out. So, at Product Hunt, do you want to kind of talk about your current architecture as of today, I guess, and then we'll go into a little depth after that?
Okay, cool. So a little bit of history, Product Hunt started as a traditional Rails app 4.5 years ago. And it's right now grew to what it is right now. And it's it uses Ruby on Rails in the backend, a Rails monolith, a Majestic monolith. And we only use Rails as a GraphQL server. We use GraphQL since a year and a half ago. And in front of that, there is a server-side rendering Node.js app, which does our React server-side rendering. And in the front end, we used React with Redux, with Apollo, and we use found as a router, and pretty much a lot of custom things, because we are using React since 3.5 years ago, and a lot of things we built ourselves because they weren't invented back then. And that's basically the high-level architecture overview.
So what's your role right now at Product Hunt? Kind of what are the main things that you work on?
So right now I'm the head of engineering. That means that my job is, when people in the engineering team have arguments, I have to decide where we go. Also, I'm doing a lot of architectural decisions, and also I'm doing full-time development on different Product Hunt products. My biggest focus right now, product-wise, is called Product Hunt Ship, which is software as a service for makers, which helps them launch and build community around their product.
All right. So, Rado, can you tell us a little bit about the story of React in Product Hunt? How did you start using it? Is it from the beginning, or there was a transition?
Yeah. So the way we started using React, when I started 4 years ago, Product Hunt was traditional Rails app. It had a couple of jQuery components, and we had to And the goal about it is we have to add like a search. So we added Backbone because I was very proficient with Backbone back then. And Backbone was cool, but the problem was we needed to build a better search. Like we needed a bit more live search with live stuff, and we decided, okay, let's do React here. So we used React for the search because the search didn't need server-side rendering, and we started using React there. Then we started using React components here and there, here and there, here and there, connected them with the Flux store because Flux was back then the rage. And this slowly, the React component started slowly eating pages. Like we moved one page, then another page, first couple of models, then the other page. Soon the whole site was basically React. Google was indexing Product Hunt quite well, but we needed something a bit more server-side rendering for Google mostly. So we implemented our own server-side rendering, which was kind of weird. Then we built another one when we moved Product Hunt to be fully single-page app. Like back then, what happened was you go to a URL, the URL just renders React. Then we moved to React Router, where React Router was responsible for rendering. And then we extracted a proxy in front of our front end, which was the React app. And it was doing the server-side rendering for us. And we slowly started killing Rails pages and move everything to React Router. Then we started DDoSing ourselves with the server-side rendering because we are on Heroku back then, and we were hosting on a Dynos on Heroku. That's like a container. We were hosting a Node.js app and a Rails app, and we were talking with them, talking directly for performance reasons, and Node is faster than Rails, and it was overburdening the Rails servers, and we were having auto-scaling. This was killing the database. So we then moved the architecture to AWS, where we have like a cluster of server-side rendering app, cluster of React app. Then when Rails app, that's when we moved to GraphQL. And right now we are slowly just killing Redux in favor of just using Apollo.
Wow, horror story that rings many bells. Here at ZocDoc, we have a similar migration from Backbone to React in the front end. And this is interesting, like the communication between servers, like as soon as you start going to this microservice world of separating services for this, separating service for that, you're starting to have a lot of like DevOps complexity, right? That starts like crippling on your application.
Oh yeah, definitely. Like that's the reason we are mainly staying on the Rails course. Like we have a couple of microservices. We have a couple of bigger ones, but we killed them because the features they were working on didn't work. But that was actually the main reason we actually switched to, one of the reasons we switched to GraphQL was GraphQL is a really nice API gateway pattern. Like the API gateway pattern is you have like a single point where your API is working, and it uses as a shield where you can have multiple microservices, but the client doesn't care. Like the GraphQL does the routing. So one of the reasons we moved to GraphQL was, okay, maybe Rails is great right now, but at some point we might start adding minor apps in the future where we just plug them inside of the main schema and like slowly migrate there.
That's nice. So like you're still trying to maintain like a simpler, like monolith application, but the React servers still need to be separated, right?
Yeah, that's the main reason. Like we try to keep it as simple as possible. Like monolith makes sense for us because we still don't know what the logical separation of concerns in our application. And in the front end shouldn't care about that. And the GraphQL gives us this very nice way of declaratively say what data it needs and how to mutate the data with the Apollo stores. And in this way, in the future, we can be flexible. Like right now, Product Hunt follows very well the Connolly law, where a software system uses the communication patterns of a team. So right now, Product Hunt is just 4 people, and we are growing up to 6 right now. And the idea here is if we have microservices, this will slow us down because it will create a lot of knowledge silos, and it's easier for an engineer to work on a monolith for the business logic and then move up to the app. But when we find out something that can be used for a single service, we would use it. Like we had like a recommendation engine built on Node with like a memory graph database and stuff like that. So we had this as a separate service. It worked quite well, but it turns out business-wise we didn't need it, so we removed it.
Nice. That's interesting. All right, so we'll get to the GraphQL part and the SSR horror story soon. First of all, how was the adoption of React? How painful was it? Because you said that you were using Flux, and we hear a lot of stories of like people just being confused, and most of the databases I've worked with that were like spending years of work. The early work of the React components is like really messy and complicated. It's like really showing how people were struggling to get the model right in the beginning. So how easy was that for you?
I mean, it had its hard moments. Like time-wise, when I think about it, like right now, if you ask me, it was painless. But now when I start thinking about it, like I can remember a lot of like wow and bug moments. Like for example, when we were losing Flux, the original Facebook Flux, the way it worked back then, Flux, it had like an instance of your store, which was just accessible as an instance to the whole app. So with server-side rendering, in a couple of pages, people see Flux state from other people before the initial rendering. Like this was a server-side rendering bug we were finding out. So what we did was the simple fix was just after every request, just clean up the store, which is not very, how to say, clean, but it worked. Also, the problem, especially in the early days, was exactly the communication pattern. Like, for example, Product Hunt has a vote button and you have multiple posts on the page. So when you click vote, all the counters should increase. And all the counters should say if the current user have voted or not or shouldn't. And it was very confusing for people. Okay, where do I keep this state? Where does this go? But the way we handle things is usually we do stuff and we notice patterns. Like we see everybody is copying the same piece of code. So, okay, let's build an abstraction of that. So the early days, we had a lot of open source projects to deal with stuff like the API level. We have something called Duxu, or like I cannot pronounce that. It's basically a declarative way of you to define, okay, this is my REST API and how to connect with that. And we have the high order components which deal with that. Initially, we had a lot of React mixins, which were cute. Also, we had a couple of problems with the React router because every update pretty much blocks us for months. That's the reason we are not using it anymore and stuff like that. But it was a slow process. Like, I think we are lucky in the terms that the Product Hunt of the product changes a lot during that time. And we are very aggressive of killing features that didn't work. So basically, we didn't have a lot of migrations. We just killed the features. So we were very lucky that the main stuff worked. But there's still some artifacts even to this day. For example, the way we do our models is still the way we did it like 4 years ago, 3 years ago, because it works. And it had so much hidden logic there already that it works. We don't touch it. I would love to go, like we use models like the React portal stuff for the new stuff, but the old stuff just uses our old model system. And I'm surprised these things work, but it works. It's every React update, we have end-to-end tests for it, so we don't touch it much.
Yeah, that's great. We're trying to have our tests here as much like implementation agnostic as we can, so we can be sure that like even if we change like technologies now or in the future, like we can still make sure that the old stuff still works, because like revolutions just like change everything that we have at the same time is really tough. And when we have this opportunity of just like killing the old features without ever migrating them, this is like the best of the scenarios for migrations.
Yeah, one thing we do, like, yeah, we do a lot of end-to-end tests with us. Like in the Rails world, we have this thing called Capybara, which launches Chrome. And I actually have a blog post about a couple of tricks we do to speed up the test. For example, we use data test attributes to mark elements. And this is independent from React. It's independent from everything. We use this for years now. So if I change the front end, I just have to keep the data test attribute. And also the hidden value of having like marking, okay, this value is just for test here, is that when I'm doing changes in the UI and I see, okay, there is this data test attribute, maybe there is a test about it, and go and fix it. And we have a lot of tooling built in for end-to-end tests. I wish to have more, but again, it's like how much time you spend on building internal tools, how much stuff you build on features. I'm not very interested. It's an interesting discussion.
So what are some of the reasons that you all are even messing around with server-side rendering? I know that there's the typical use cases, but in particular, I'm kind of curious why you think Product Hunt feels that the need to use server-side rendering over just all client rendering.
So basically, it's one reason. Server-side is Google and SEO optimization. Like Google is a very important traffic driver for us. And this makes it very important for us to have server-side rendering because it's very important for that. Also, it's helpful for mobile clients. And also there is a couple of tricks we were doing back in the day when we had like performance issues. Like right now, we still support that if we need it. But for example, we have Cloudflare CDN in front of product. So we had this switch where we had more traffic. If you are not logged into the system, like you're a visitor, the site for 2 visitors looks the same. So we added Cloudflare caching for 5 minutes. So you are seeing a 5-minute old version of Product Hunt. Because Product Hunt, it's not like a real time so much important. It's important to be live as a system. So without server-side rendering, this wouldn't work. So when we have server-side rendering, what we do is we have Cloudflare. We turn off this page caching on Cloudflare for people who don't have cookies. So when they come to Product Hunt, they see 5-minute old version. Product Hunt is hit for a visitor every 5 minutes. This reduces our traffic load on spike and only like logged in users, which are big chunk of our users, but the biggest chunk is not logged in users for a product like Product Hunt. So this actually was a good way for us to scale and have like a cost saving on performance. But the main reason is still Google.
Interesting. So yeah, I kind of assumed that a lot of it had to do around server-side rendering, but you did, around SEO. But you mentioned that it helps for mobile clients. Are you saying that it's faster for people that have like latency issues and slow connections as well?
Yeah.
It's more performant in general?
Yeah, because the way it would work is we do the bunch of the data fetching and folding the resources. So the mobile client can actually see the page, how it's rendered. And for us, most of the Product Hunt is showing content, not so much interacting with the content. So seeing the content is very important for them. So the way we can have this is we do it. The users just get like a gzip version to Cloudflare and all of that of our page, and the mobile client can look fast. Like again, the React has to pass, fetch, like make it active, connect it to the tree and whatever. But in the end of the day, they see the content faster, and it feels faster. Like we also have a lot of helpers. We can do a better job with mobile with everybody, but we also have a lot of helpers during the server-side rendering where we cut stuff for mobile clients. Like when you do the server-side rendering, we have helpers where based on the browser engine, we know you are on mobile client. So we don't render a sidebar. And we don't render it like at all. And this is one of the reasons I'm really waiting for Suspense to be more available, because we would even do the cost splitting there. So for the mobile client, you get like a smaller bundle and stuff like that. And with server-side rendering, this is easier to do because we can give you a different bundle and stuff like that.
How do you detect it's a mobile request from the server?
There is this library browser, info browser stuff, like basically on the user engine. Based on the user agent, you see what's the browser, and the browser says which OS it is. And when you know that, you can say, okay, I'm on mobile, I'm on desktop. Mm-hmm. And we have, I think I have it in one of my presentations, we have React components which are named mobile and tablet and desktop. And based on the information got from the user agent, which comes from the server side, we can render those components. And this gets to Redux to hydrating the store, and we can use that seamlessly to the pages.
Yeah, because that part of server-side rendering is a big issue here. We started working with always render the mobile version, deliver in even if it's desktop. If it's desktop, it will. But some components get really weird on the desktop before. If you have a different component from mobile than desktop, those early seconds can become really weird. So what we end up doing is that most of the responsive logic is via CSS. So that leads to less weirdness, and we do some user agent detecting too now.
Yeah. So we also used a lot of media queries, but the way we actually we usually, for example, the sidebars on the pages are not rendered. Also, we are doing a lot of things with deferred rendering. That's how we called it. The deferred rendering means when it's server-side rendered, during the SSR, we don't render certain things in the page. And when the page loads on component did mount, that means, okay, it's in the browser, load them afterwards in a second batch. That's the reason the user actually sees something fast. And then we do the less meaningful stuff. And also it gets the UX effect of people actually seeing more content, and their actually eye movement goes there.
Yes, we do the same here. Since it's also SEO based, we try to only server-side render the SEO related content too. Anything that won't help SEO, we put on componented mount.
Yeah, I mean, one thing I'm always wanted to try with us, and it's just not priority because it works. But when you are logged in, you don't need server-side rendering most of the time.
When you're what?
Logged in. When in product when you're logged in, the server side, Google doesn't need that information because Google is never logged in, I hope. Very honestly, weird when the Google starts logging into website.
That is such a good comment and something to just talk about, because when I was first trying to understand server-side rendering, I did not understand the use cases and how to authenticate and everything like that. But basically, what I learned just kind of recently, honestly, because I've never built anything SSR before, I was working with Gatsby trying to figure out the proper way to do authentication. And what we ended up coming up with, the solution that we ended up coming up with, and this was after talking to the Gatsby people, was to basically just have everything as is, and then you have just a protected client-side set of routes using React Router on a specific route, and everything from there is handled by React Router, and it's all client rendered, because you don't really need to worry about server-side rendering after they're authenticated, for those pages at least. If they go back, of course, to some other part of the app. But yeah, that's a really good point to make, and I think it helped me understand kind of how all this fits together.
Yeah, because if you start to think about SSR, it's it doesn't make sense. It's such in React, if you one of the, I think that maybe it's changing now. Page load is getting faster with the innovations of React, but in general, page load was very fast in the world before React. When you work with templates, if you had a handlebars, imagine that your Rails app would have a super fast page load because it's just a template rendering, right? So, and the problem was interaction performance. Whenever you have those very complicated templates, changing the DOM, that was a clunky really fast. So React kind of, in terms of interaction performance, it was like, okay, so let's trade. Give me a little bit of page load so I can like mount the virtual DOM and stuff like that. And then your updates are going to be really fast, right? And can be declarative, they're going to be fast. And now we want like a page with like super fast page load. It seems sometimes I feel like, is it the right tool for that? Like sometimes aren't we forcing? Sometimes I ask myself that, because I think of the SEO. We were making an experiment with like not using React for the SEO pages. Like why can't we have like an SEO page? There's like super fast with template, and whenever you click any link in that like SEO ready page, you actually go to our React app. This was like one thing that I was experimenting at some point, but the problem was that we didn't want to maintain separate applications, so we just started making our React application faster.
Do you run your own freelance business? Or maybe you're thinking about picking up some business on the side? Well, then you need FreshBooks. FreshBooks is the quickest and easiest way to get invoices out to your clients. It's easy to use. It works anywhere, available from any device, on the desktop, iPhone, iPad, Android, and all of your data is backed up and secure. And it makes it really easy to get organized and get paid. You'll be tracking time, logging expenses, and invoicing your clients in no time. You can also save time billing, freeing up several days per month to focus on the work that you love, and you get paid faster. FreshBooks customers are paid on average 5 days faster because there's a link on the invoice that says pay me now. And it's a great way to grow your business. Plus, FreshBooks is offering a 30-day trial. That's right, 30-day trial if you try them out. So go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section. Once again, for a 30-day trial, go to gofreshbooks.com/devchat and enter devchat in the How Did You Hear About Us section.
Yeah, I mean, to think about like SEO, for example, for Google, page load is very important, like speed. They really like speedy pages. And the way, in our case, we actually cannot make separate pages because they're dynamic and they have a lot of content. But, and again, it's depending where, if your system is mostly after a login, I wouldn't like bother with server-side rendering right now because it has a lot of gadgets. Like, for example, in a lot of cases, we have to use Redux, mostly because without it, you cannot do server-side rendering. Like, I'm a big fan of set state in the places where it makes sense, and we are using it more and more. Like, I think people are overusing Redux or MobX and stuff like that. The only stuff which is in Redux right now, in our case, is stuff we need either to communicate across boundaries or server-side rendering. Like, it's the solution where because you have this hydrated store, you serialize. And for example, one hack we actually did, by the way, for the ones who actually do Redux server-side rendering, I noticed a very small hack which improved our system a lot. So usually what people do is they make a script tag with all the serialized JSON states. And this script tag gets loaded into JavaScript memory, and then we hydrate the store from this state. And this states are live. Like, a lot of people don't remove this state from memory and don't remove the script tag from the DOM. And if you do that after your page is loaded, that actually frees up a lot of memory from your app because this Redux state always stays there. And like, this is a small hack we actually did with one of our performance optimizations. When pages load, it removes the Redux state, which was the original Redux state and Apple state. So we kill those states. So we remove those states from memory, and we also start removing them from the DOM elements because it's still in the DOM as strings and stuff like that.
We got a similar situation where we were having memory leaks with styled components objects. We were creating style sheets, server-side render send, but we were not cleaning them. It was not straightforward that was happening. and then our server like started crashing every like 2 hours. So this is the kind of complexity that some people don't understand. Like they go to the server-side rendering as like, oh, let's go this fancy. People don't understand how much complexity this adds to your front-end application. If you're able to have an application that is only like client-side, as Nether said, like if you can like have an application that is served by Nginx, the assets can all be cached. It's a whole different world. Like there's all the complexity, and then you don't need to be on call that much because you don't need to maintain the servers in production all the time. It's like whenever you start server-side render, you need to ask really hard, like yourself, like, do I really need that? Like, is it really important? Is it like something that, because it is difficult. It's a whole new level of complexity that you're putting on your application.
Yeah, exactly. And if it can be like less moving parts, makes it a lot simpler. And
yeah, one problem we got here that was really interesting is that we wanted to make it even faster, right? We were using lots of Node applications. We started using the streaming library, or the streaming functionality. So instead of creating a big string with the HTML file and then sending back to the user, we were using the function that starts streaming as it builds, right?
Oh, that's nice.
Yeah, it's super cool because like the resources, we started using like 30% less resources by the time we deployed.
Oh, wow.
It is. And so it was like Node is, we think of Node as being like single threaded, but like under the hood, it actually is not. And when you use streaming is when a node can be like smarter about just sending a bunch of streaming at the same time to different people.
Yeah. Also, if I think correctly, it actually removes memory. Like when it's stream, it's actually let clean up.
That's it.
That actually freezes memory, because it's surprising how much the JavaScript app eats memory. Like there was this great talk on my conference about about how SoundCloud built their player for Xbox, because it has to live constantly. They actually implemented garbage collection for Redux, which keeps track of which selectors are used, because like the problem of a lot of things we have, like Apple doesn't solve that, is if I use Product Hunt or any GraphQL app for like 1 day, all the state I have loaded, it's there. Yeah, it's compressed. Yeah, it's like normalized, so on and so forth, but it's still in memory. And I actually don't need it. Like in some cases, like we don't have this problem yet, but I have thought about solutions. Okay, if the app is running for maybe an hour, just do like hard page reload just to clean up memory, like the hard way of like, okay, just redo all the cleanup stores, because you have a lot of garbage on the top of you, and we don't use the operation system stuff.
Yeah, and the interesting thing about the streaming is that like we were fetching data after streaming started, so we were like even more efficient, and then it brought a big problem. Sometimes an error happens in the middle of the streaming, like either maybe you will not find the entity that you're looking for, or there is even like a 500 error. After you start streaming HTML, it's already status code 200.
Oh.
So we were having a bunch of error pages with status code 200. So like we thought for a while that, oh my God, our problems are gone. But of course, like the second minute was like, that is really weird. Like there's no 404s, no 500s. And that is really bad for SEO. If Google reaches your page, you have an error page, and you have a status code 200, it's bad for SEO.
Yeah,
so,
especially for 404 pages. Like it really takes those.
That's it. Like it really hurts you. So yeah, everybody listening, cautionary tale. It's a hard subject. Don't think it's easy. One thing that I think about when I think about server-side render, and I want to start using that in production, I only use it on side projects, and it was really good, is the Next.js framework, that they have like Next.js is kind of like the Create React app for server-side rendered applications. That's how I like to think about it. They use the server-side rendering code as another like React lifecycle. So you have like get initial props, and get initial props will run in the server if it's the first request. And then after that first request, the application becomes like client side if every asset is loaded. So that seems like a really interesting like compromise. And I like those no configuration tools because they let you like focus on the product. Like you're focusing on like make your product better and better and waste less time with accidental complexity. Sometimes a lot of times these frameworks, they don't give 100% of what you want, but if they can give me like 90% of what I want, I'm already happy with it. So I would love not to have to deal with all those details of server-side rendering. We are planning to do like a small experimentation with Next.js here too.
Yeah, Next.js is awesome. Like I have done a couple of side projects. Like when we started it, Next.js didn't exist. And for me, actually, the biggest issue with the Next.js is like I actually see them like the Rails of the React world, because they actually give you application structure as well. For me, it's very like the big problem in the React world. We don't have a good best practice for structuring data, like how we structure a bigger application, how we split them into modules. The thing I don't like about the React router is the Next.js is the router. It's in like, for example, in our application, we use very advanced routes. Like we have a lot of routes which are aliasing to each other. Also, I'm using the URL as a stakeholder for a lot of things. Like, for example, if you have filters, I never put those in Redux. I put them in the URL, because when I change the URL, it changes my whole state. And actually, I have a free bookmarking URL. And the Next.js have a lot of places where they have big issues with dynamic URLs in the beginning. I think in the new version, they solved that and stuff like that. But for me, that's the biggest drawback is the router, because they use the file structure, which is simple to start with. But for example, I have a page where right now I'm building this page where you have a URL which is job/new/ a token of like a job to like go back to the previous job you created. And I also have job/discounts with a custom slug for the same page, but with applied discount. And this is the same React page, totally the same, but it's quite hard with the font router we use. We just use the same React page, but with Next.js it will be a bit more harder. But I haven't played much with it.
Yeah, I can say that. Yeah, I did not delve into any like advanced router stuff with Next.js, but I'll keep my eye.
So we've been talking a lot about the web, but you all are using React on mobile as well. Do you want to talk about how Product Hunt is using React Native and kind of like how that's changed over the past couple of years? Because I know you all have done some strictly native stuff as well.
Yeah, so a bit of history. So originally we actually didn't start React Native because it didn't exist back then. So the original Product Hunt app actually was built in Objective-C because Swift was not production ready back then. Then it was migrated to Swift, and then we moved to React Native because we needed an Android. And also our app had a lot of features we don't want to have anymore, like a lot of things which we don't have on the product level anymore, a lot of like failed experiments. And we started like last year, I think November or December, like one of our engineers, Vlado, started working on the React Native stuff. And the idea was we use the React Native for our iOS and Android clients. So the goal was to have an Android client. And also we were using a bit of let's say utility classes, because same JavaScript, like utils, a lot of style guide stuff. Like we have this style guide, dot is in Bulgarian. It's styles.json file where we have all our like, okay, this is the colors we use, the fonts we use, and we can actually use those things across the application. Also, our current version uses Apollo, which simplifies a lot of the data fetching. Like we don't deal with REST anymore. And yeah, we have a couple of issues with React Native recently, based on their architectural changes, and the ecosystem there is a bit immature. Like, for example, the navigation part was breaking time to time, every update. Like, if we don't update the app every month, like just do npm upscale, like we skip 3 months due to like feature prioritization, you spend a lot of time of just, okay, this is change, this is change, this is change. But it's getting better. Like there was this talk on the React Conf about the new React Native stuff, which I'm excited about. And also, like, the biggest issue with React Native is debugging. There's a lot of crashes which come inside of iOS or Android, or the React Native